Je peux aussi, je parle français, mais je vais faire la présentation en anglais. Mais s'il y en a un problème, on peut toujours m'arrêter et poser des questions, ça ne me gêne pas s'il y en a des questions au milieu de la présentation. Alors, je vais parler un peu de... No, I said I would speak English, I'm sorry. I will talk about aquaponics. And I'll talk about how I rather quickly had to learn several new disciplines in order to build something real in my garden that potentially one day will be able to supply vegetables and fresh fish for my family. And in the process of doing that, I became unwittingly an aquaponics pioneer in France. I will see if my remote control will work. Now, aquaponics is not really very well known in France particularly. In the United States, in Australia, a lot of people know what it is. Here, most people will say, what is aquaponics? L'aquaponie en français. It is a combination of aquaculture and hydroponics. Aquaculture is that you intensively will raise fish for food, like usually it will be in big tanks, and you give them exactly what they want to eat. You get rid of the waste products from the fish and you keep them happy. And you can have a lot of fish in a very small space if you take care of all the conditions. You make sure the water is well oxygenated and the pH is exactly right, etc. It's a bit technical. And hydroponics, that's that you grow plants without soil. You give the plants exactly what they need. You keep them in some kind of substrate medium, or you keep their roots directly in the water, and you give them, you mix minerals together to give the plants exactly what they want to eat. And that can be very productive systems as well. The problem with both of these things is that, well, they work very well, but they're also a little bit wasteful in the sense that you feed things into the system and you have waste products. Like in aquaculture, like the water will end up being polluted and you throw away the water regularly and add new water into the system. And in a hydroponic system, you mix minerals, essentially chemicals, into the water in order to get the nutrients right for the plants. And eventually, you can't use those chemicals any longer and you will throw the water away. It's not a huge environmental catastrophe, but both of them are sort of wasteful. So the point of aquaponics is you combine the two systems and you have zero waste. Like essentially what you do is you create an ecosystem, a cycle, where the fish waste, meaning the fish will eat, you give them something to eat and they will essentially crap in the water, and that produces mostly ammonium. And if the system is well established, then there will be bacteria that will convert ammonium into nitrites. And there are other bacteria that will convert nitrites into nitrates. And nitrates is some of what plants particularly eat. So you can fertilize plants with the nitrates that come out of the fish waste. And in turn, the plants and their grow beds will clean the water. They will filter the water for the fish, and you can return clean water to the fish tanks. It has to be quite well balanced, but essentially it's a work of genius that that's even possible, that you can create an ecosystem that both produces fish, where the fish will feed the plants and the plants will clean the water for the fish, and there's zero waste. Well, here it is explained in French also, saying essentially the same thing. So the point is, it's relatively new. It's kind of an obvious idea when you look at it. It's what nature has done all along. In nature, you have animals and plants together, and they're part of the same system. And everything in nature is part of a cycle where the waste products of one will be the food for another. And we can very well see that plants will grow next to fish in ponds and so forth. So it all makes good sense. Now here's a little simulation of how a typical aquaponics system will work. You have a fish tank that has fish in it, and the water will run out of the fish tank regularly. There are several different possible arrangements, but this is pretty much the system I'm following. The water will run into a sub-tank where the water level will change all the time. From there it's distributed into some grow beds where you have plants. And those grow beds will continuously be filled up and emptied. The grow beds are filled with some material like clay balls. And the siphons is a system of how you empty the grow beds automatically. And that will run continuously. This system has just one pump. It has just one pump. And like the water will leave the fish tank by, not sure what's happening. It will leave the fish tank essentially by gravity, and the pump will distribute it further on from there. So now there are several reasons why that's a good idea or why that's nice to do. If you have a system like that, you could become self-sufficient. You can grow your own food by yourself. There's an element of resilience, like you do it all by yourself. It functions in your backyard. If somehow the supermarket is closed, then you still can have food. You create organic vegetables for yourself. There are 0 chemicals that go into the system. You can eat the fish, so you could have fresh fish in principle anytime. You know exactly what they've been eating. There's 0 waste. There's nothing that you throw away. Everything that goes into it stays as part of the system, as a small ecosystem. It's a fun thing that combines several different disciplines together. You have to know several different kinds of things that otherwise normally are separate. And also generally because it's a cool thing to do where you have to invent something new or copy what other people have done, and everybody's sharing the information, and it's loads of fun. Now it started with that I read a book just at Christmas, around Christmas time. And after I had read that book, I told my family that I was going to create an aquaponic system in my backyard. And they didn't really believe me, because normally I don't do that kind of things. I'm a programmer. I sit inside and work at my computer. I'm also sometimes a coach and a counselor. I do speak with people. And I'm a bit of a philosopher. I like to think about things and write about them, but that's all stuff I can do sort of inside by myself. Normally I don't do things. In my family, it has traditionally been my wife who's been outside making vegetable gardens or tinkering with power tools in the garage, and I've always been very hard to persuade to do that. But somehow there was something about aquaponics that attracted me. I think it's in part that it's rather complicated and technical, so it's not just gardening, it involves machines and pipes and so forth. So I made a plan. Still nobody believed me, but I figured out sort of the basics of Google's SketchUp. And that took me a little while to figure out where everything should go. I want a greenhouse. I want it out in my backyard. Figured out the dimensions and roughly what the pieces would be. And the fish tank would be the thing in the corner. It's called an IBC tank, which is used for industrial transport of liquids. It's rather cheap, about 100 euros. You can cut off the top of it, and it's a wonderful 1,000-liter fish tank. And the rest of them will be grow beds and some buried sump tanks to regulate the water level. But the problem was that this is how the place looked in my backyard. There's a lot of work that needed to be done. This is where I wanted it to go. well, it took about a month of digging in the backyard. It wasn't quite as glamorous as my aquaponic system was meant to be, but it took a lot of work to make just a frame for a greenhouse, and I had to learn some things about it. It has to have the right size, the right dimensions. You don't see it yet, but it's being insulated by dug down polystyrene around the edges so that the foundation will be insulated in the winter when it will get cold. And it advanced. We also have chickens. That's one of my wife's projects. And the tanks are already dug down. It's starting to get somewhere. This took like a month to do this, of heavy work that I worked several hours in the garden digging holes, and eventually we can put up the greenhouse. And now there are some things to learn about it, like plumbing, putting together pipes, like what kind of pipes, what size, how do you put them together? How are they in the right order? Where do you put the pump? How do things leave a tank by gravity? There's a lot of things to understand. Biology, I need to understand fish, like what do they eat? How do I keep them alive? What kind of type of fish to choose? It's not that easy. Chemistry, they need to live in the water, so the water chemistry needs to be right. The pH value, where I live, the pH is way too high, and the hardness of the water is really low, which makes it a very hard chemical problem, how to lower the pH without making the water chemistry very unstable. I need to know about gardening. Obviously I'm going to grow things, so I need to understand what kind of seeds to plant. What does it mean if the leaves are yellow, or which plants can I plant next to each other and so forth. I need to do construction, like the insulation, all these different other parts. So here I'm working on insulating the buried tanks, like there are two tanks that are connected together underground. I need to drill holes in various plastic tanks that need to be watertight. Well, eventually, now we're in April. I started in the beginning of March, actually. It took me a while to get going at first. And it seemed like many months, but it was only about a month before the greenhouse was actually standing there. There are actually some tanks in the ground. It's beginning to look like something. There's the IBC tank in the corner. I haven't cut open the top yet. This is where the grow beds will go. It's a lot of components needed. Well, the greenhouse, these various tanks, pumps, pipes, cement blocks, and so forth. And this is really only a small part of it. So lots of things go into it, and as I mentioned, part of what motivates me is that it's kind of complicated and technical. So there will be a lot of diagrams like this. This here is the siphon that will empty each of the grow beds, and you don't really have to look at the details, but here are some of the parts, and part of the fun is that you get to put pipes together and experiment with them. So here's when I'm testing it the first time. Like essentially it will fill up, and then the thing on the right will empty it when it's full, and then when it's done it will fill it up again, and so forth. And that's how the pipes look underneath, where we let the water out. It's not working very well, my remote control. And in these various grow beds where you have plants, we'll fill them up with some kind of material, typically. The most common one is clay balls. And all these clay balls need to be washed, like it's about 1,000 liters of clay balls, and they need to be cleaned before you put them in there. That takes days and days, and plus they're heavy. Well, they're actually rather light. The point of using them is that they're relatively porous. It's expanded clay that has a large surface where bacteria can grow, and part of the secret of a system like this is that the bacteria that exist in the system, it wouldn't work if there weren't the bacteria that would convert the fish waste into nutrients for the plants. And part of the secret is to have something they can grow on, which are those clay balls. Okay, now they're in the right place. We're in May, about 5 months ago. I've put clay balls in the first grow bed. I put a few seeds in there, and there are some cucumbers that are starting to to move. The circuit is already going, even though I haven't really finished it, but it's filling it up with water and emptying it. And there are about 5 goldfish in the big 1,000-liter tank, very small ones. Still in May, a little later, I filled up more of them, put some other things in there. It's still a mess. I'm building a lot of stuff. I'm trying some crazy things like a banana plant, just to see what would happen. We're in June, and now I've filled up all the grow beds, and things are growing a little more, but not really all that much yet. But it's starting to take off. Months later, everything is bigger. There's some big zucchini growing in there to the left. Some of it is taking off. The banana plant is bigger. And well, I need more fish, and really there was a lot of thinking that went to what kind of fish would be the best one. Traditionally, the most popular fish in aquaponics is tilapia. Tilapia are African fish which are absolutely perfect in that they grow really quickly. In about 6 to 7 months, they can be full size, so that you can actually can eat them. Plate size, one calls it. And they're vegetarians, and they're very easy to deal with. They can tolerate just about any water quality, and they will reproduce very easily. The only problem with them is that they're African fish. They need warm water, and I'm putting this in a greenhouse outside. It would have been nicer to pick some local fish that can live in cold water, but they had other drawbacks. So I picked the easy to deal with African fish, but I have to insulate my greenhouse really, really well, and I have to heat the water. Anyway, these were very hard to get. They actually didn't exist in France at all, and importing them from England, which was the closest place they had any, was rather tricky. But here they just arrived sometime in June. They eat like crazy, and they grow very quickly, so July they're already bigger. August they're even bigger. And this was like last week. It's maybe a little hard to see, but they're about 20 centimeters long. They started being about 1 centimeter just a few months ago. And of course, part of my motivation is that this is kind of technical and I can do fun things with it. So they're underwater webcams, so I can look at what the nice fish are doing. So that's what you're looking at here. So that's part of the fun about it is my greenhouse has to be networked, of course, so there was a problem, how do I get Ethernet out to the network, and there are now 2 underwater webcams and another webcam to see what else is going on. And I tried all sorts of different things. I ended up just stringing an 80-meter cable out to the greenhouse that works well right now. Now in August, the cucumbers have already reached the ceiling, and there you see cucumbers hanging there. October, this is just a few weeks ago. And you can see some of it is growing like crazy. There are cucumbers hanging there. You can see the banana plant in the back is enormous. There's lots of tomatoes, lots of different things going on. And stuff starts being edible. This melon was delicious. And now that leads to other projects, side projects. The system is working very well right now, so I can continue with some of the other parts, like insulating it. I had accidentally bought a greenhouse kit that was much too thin, that wasn't really made for being really well insulated in the winter. So essentially I had to cover it with one more layer by myself of polycarbonate with the air pockets in between, which is another project, but I'm in the process of doing that, so I put it on one of the walls there. Another project is to collect rainwater from the top of the roof of the greenhouse, at least, because the rainwater would actually be better in the system. Various other side projects. There's a well in my backyard. It would really be better if I used the well water for the system. The target is that it will be a closed ecosystem where I have all the pieces locally. I haven't really gotten very far on that part. I got a stack of solar panels delivered last week. This uses quite a bit of electricity for the heating. The pumps is not a big deal, but the electricity is a bit of a worry for the winter. So I will try to construct solar panels that can cover the electricity. And of course, having a system like that, there's lots of fun stuff one can monitor and control. I haven't gotten very far in that. The first target was that it actually works and the fish stay alive and the plants actually grow somewhere. But there's a lot of things that can go out of control if you don't watch it very well. Like what if the water flow stops in some parts of it? What if the water level is too low? Some of the water will evaporate. What if the temperature is wrong or the pH? So that stuff you can easily tinker with little electronics Arduino devices for monitoring and controlling some of that. So that comes next. So part of what's fun is this leads to a whole bunch of other things that I didn't particularly think about. It was just a fun project to do. But it leads to working, like I just mentioned, monitoring, automation. You think about the economics of scale. Like I thought it was a rather large greenhouse, 9 square meters, but really it's very small if you want to have an efficient operation. You actually want to grow something you could end up eating most days, and in the family is not really enough. So if I did it again, I would do it much larger. But it makes you think of whether it's really efficient or a good way of producing something. You think about self-sufficiency. You quite easily get into various kinds of community networking. People will ask about this. Your neighbors will be very curious. Other people will want to do similar things. You meet people who do other parts of a similar puzzle. It connects with transition networks, people who work on resilience and how can local communities be more self-sufficient. How can you grow your local food? How can you know what local expertise you have in your area, and so forth. Urban gardens, this is something you can quite easily do inside. It doesn't have to be in a backyard. You can do it on a balcony, you can do it inside with artificial light. It's, there's a lot of possibilities in it, and you can do it. It can cover food needs in many areas where you otherwise wouldn't expect to grow something. It makes you think about permaculture, because it uses some permaculture principles of there's zero waste in the system. You essentially help nature to do it yourself. You intervene very minimally in what the system is doing. You basically just set it up. And it makes me want to do other projects in the backyard, which didn't interest me before, but now I look at it a little differently. It makes you connect with people who make things, like the people you meet at a conference like this, Fablabs and so forth, because you need parts. I did this in France where almost nobody had done anything like that before, so I had to figure out all the pieces myself, how to do it, where I find them. Some pieces don't exist, so it would be very useful to have friends who could help you fabricate parts of it or tell you where you find stuff. It leads to speaking to you here because people often are very interested in subjects like aquaponics. As I mentioned, very few people have done it in France before. There is a little forum. There are not very many people on it. I kind of expected there would be more people who did it, but I became a pioneer in being sort of the first person who did sort of a real aquaponic system, like one would do it in the US or in Australia. My system is really rather average or standard, the way you would do it in many other countries, but in France it didn't really exist before. So I became sort of the poster boy for aquaponic systems in France. And this is not my forum, but you'll see actually my system is part of their logo now because they're all very proud of me having done an aquaponic system. And that's about it. So if this was my adventure as a maker and as a gardener, as a fish grower and various other things. If you yourself are already making things in your life, excellent, just keep doing that. If not, I hope that adventures like mine can inspire you to get crazy ideas about things you can do and build and make in your life, and that you figure out how to do it. So thank you very much.